Alright, today we're going to talk about general angles. You guys already know how to measure angles, but we're going to deal with them in a slightly different way. We're going to talk about them in standard position. So, like I said last time, trigonometry is just triangle measurement. Talking about triangles, it's used in all kinds of stuff. But let's get right down to business. It takes two rays to make an angle. You guys know that. One ray, second ray, you have an angle. In standard position, an angle always starts from the positive x-axis, and so we're going to draw it from the positive x-axis going out this way. That's called the initial ray. Initial, the starting ray, anything like that. And then we go counterclockwise. All angles, when we're talking about standard position, go counterclockwise. And ends at the other ray called the terminal ray. Where stuff ends, the terminal ray. And so 60 degrees, less than 90, so I'm going to draw it like this. And that would be a 60-degree angle. Started at the positive x-axis and went this direction counterclockwise. If you want to, pause the video and try the next two on your own. 150. Starting from the positive x-axis, you're going to go past the 90-degree mark, which is the straight up and down, and then almost to straight across, which would be 180. And so that would be 150. We can also have negative angles, which end up going the opposite direction, just like negative numbers are the opposite. And so we're going to go around clockwise this time, past 90, past 180, and 270 is 3/4 of the way around. And so this is equivalent to a 90-degree angle going the other way, and we're going to call that coterminal here in a second. So this is negative 270 degrees, and like what I was saying is that this is the same as if you had just gone around this way, or it shares the same angle. It is not the same angle, they're not equal, but they end up in the same place and they have some of the same qualities. And so if you share a terminal side, we call it coterminal angles. Just like coworkers share a job, coterminal angles share the terminal side of the angle. So, if we are to find two angles that are coterminal with 150, all it is, let's draw our 150-degree angle again. $150-degree angle. If we go around one more time, you would be coterminal, just one more revolution. Or if you went around the opposite direction. And so really, to find coterminal angles, we add or subtract one revolution, plus or minus 360, or any multiple of it. So if we did 150 degrees plus 360 degrees, so if you've gone plus 360, so that'd be 410 degrees. Would be which would be one coterminal angle with 150. Or you could go the other way and you could subtract 360. So 150 minus 360 would be 210. Because this time we're going around, and that's 30 degrees past, and so I should just keep that as a negative 210-degree angle. So those are two coterminal angles. So in order to find coterminal, just add some multiple of 360. We can write this as a formula because all it is adding some multiple of 360 to it. And so we could represent that with 360 times n, where n is an integer. And I'm going to use that theta to represent all the angles coterminal with 150. So because n is an integer, it could be positive, could be negative, and that spits out all the coterminal angles. So we're going to be dealing with a lot of the same angles over and over again because we're going to be dealing some with specific angles. We dealt with those special triangles, 30, 60, 90, and 44, 45, 45, 90. In the last lesson, we're going to continue that. And so in order to do that, we're going to use a unit circle. What a unit circle is just a circle with a radius of 1. And so if you want to spend the time right now, if we were in class, we'd go and do that. I'm going to make a separate video. But go and fill out all the 30, 60, 90. So it would be 30, 45, 60, 90, 120, and so on, all the way around that circle. So where do degrees come from? How many degrees are there in one rotation? We've talked about that. There's 360. But why 360? We sort of become accustomed to it because we're used to it. But why in the world 360? Why not just 100? And so the Babylonians are the first who actually established this 360. And it was based on their calendar year, because they noticed that all these stars that they were following rotated or moved about 1 degree every single day. And so they based 1 degree off of how much those stars moved. And that's where 360 comes from. But you guys are so used to that, and the whole reason I say this is because I'm going to teach you about radians, which are very different. Now, I know you're attached to degrees, but we're going to talk about radians, which are nice because they're unitless. And so keep that in mind as you become a little bit confused as we talk about radians, because it's something new. So, what are radians? Why do we need them? We're moving into the world of advanced mathematics. So, and what we use are radians a lot rather than degrees because they're made easier because they don't have units. What the radian is just a ratio. It's a ratio of arc length. And let's say arc length is the S represented. Imagine you have a tape measure, one of those floppy ones that you could measure how much is going around the circle. And then if you divide by the radius of that circle, you get the amount of the angle, the amount of radians that you go through. So imagine if you had this arc length was the same. So imagine that this is about the same as this radius. That is 1 radian. Because this, say it's 2 centimeters, divided by the radius, 2 centimeters, gives you a ratio of 1. Now if I double that, and I say this whole arc is 4 centimeters, and I divide by the radius, which is still 2 centimeters, then that whole one would be 2 radians. Now, I don't have to use radians, I'm just saying it over and over again, because the 4 centimeters divided by 2 centimeters, the centimeters cancel out and you just get 2. And so, with an angle being 2, we don't even have to say 2 radians, we could just say the angle is 2. And so, radians are unitless. So, 360 degrees in one rotation, how many radians? Well, think about if you went all the way around the circle. If you went all the way around the circle, on the outside, that's what we call the circumference. Circumference. You guys learned about how the circumference was 2 pi r. So if we found the angle that you go through to go all the way around, the angle in radians would be the circumference, or the arc length all the way around, 2 pi r, divided by the radius, which would be r. And so the total amount, if you cancel this out, there are 2 pi radians in one revolution. So 360 degrees in one time around and 2 pi radians one time around.